Hi everyone, let's solve this problem. Koko eating bananas. Koko loves to eat bananas. There are n piles of bananas. The ith pile has piles of 5 bananas. The guards have gone and will come back in h hours. Koko can decide her bananas per hour eating speed of k. Each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. So basically she can eat only one pile per hour. She cannot share between two piles if she finishes within the minimum hour rate which she chooses. Coco likes to eat slowly, but she wants to finish eating all the bananas before the guards return. So we have to check what is her rate possible such that she can finish within the hours available to her. So we have to find the minimum integer such that she can eat all the bananas within h hours. So let's try to understand this problem. So let's say these are the piles and these are the hours. So basically let's say k is my hourly rate. In that case, if k is 1, what happens is for this particular pile, for the first hour for the first pile she'll need 3 hours, for the second pile she'll need 6 hours, which is already greater than 8, so we cannot continue further. Let's say for example if my k is 2, in this case she can eat 2 bananas per hour. That means she'll still need 2 hours and then 3 hours for the second pile, and then again 4 hours for this third pile. So it is still greater than 8. If you see, this is 9. So we cannot choose k equal to 2. If k equal to 3, in this case the first pile will take 1 hour, second pile will take 2 hours, third pile will take 3 hours, and fourth pile will take 4 hours. In this case also it's 7, 9 and 10. 10 is greater than 8, so we cannot go with k equal to 3. Let's consider k equal to 4. In this case, first pile will take 1 hour, second pile will take 2 hours, third pile will take 2 hours, fourth pile will take 3 hours. So in this case 5, 7 and 8, it is less than or equal to 8, and we found the minimum integer, right? So 4. If I take anything above 4, it will obviously be greater than the value 4, so we don't really have to proceed further. So this is the brute force approach. So basically what are we trying to do is we will go till maximum of piles value. For example, in this case 11 is the maximum value, so I can go till from k equal to 1 till 11, and I will be finding the minimum integer k, right? And then for every k we are trying to calculate the total time taken. So it is nothing but n, considering n is the number of elements in the piles, right? This is how it looks. Now we can solve it even better by using a binary search. It is going to take log of max of piles and into n. So we are going to optimize finding k value. So for that, let me explain it here. So let's take this array 3, 6, 7, 11, and hourly rate is 8, right? So now I have k values from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 will be the maximum value. So this is my search space. This will be the lower bound and this will be the upper bound. So in this case, what will happen is we'll find the mid value. This is the mid value, and our current answer will be 11, the maximum value. Mid is 6. Now I'll check the total time taken here. In this case it's 1 hour, and then 1 hour for here, 2 hours for this, and for 11 also it is 2 hours. So it is 6 hours. 6 hours is less than 8. So we actually found an answer. So we'll update our answer. Now we will never go beyond 6 because we found a better answer, 6, right? So I'm going to remove the other search space. How are we going to do that in binary searches? By updating our R value to mid minus 1, and now my mid will be at 3. So let's again compute the values. So if I am eating 3 bananas per hour, this will take 1 hour, this will take 2 hours, and this will take 3 hours, right? And then this will take 4 hours. So in this case, it is 4, 7, 9 and 10. 10 is greater than 8. So this is not the answer. In that case, if 3 is not the answer, anything less than that cannot also be the answer, right? So what are we going to do now? We are going to update our low pointer here, and now the mid of 4 and 5 will be 4 itself, and here in this case let me again calculate it. It will take 1 hour, and then 2 hours here, 2 hours here, and 3 hours here. So in this case it's 5, 7 and 8. So it is equal to 8. So anything less than or equal to 8 would be a good answer. So we found 4 as our answer. Now let's again, when we find the answer, we'll update our answer and we'll try to see if there is a better answer, right? In that case, R will be moving to mid minus 1, right? If my R pointer moves to mid minus 1, then our binary search condition breaks because R pointer is greater than L. So this is not going to be working, right? So we have to come out of the loop, and we found the answer as 4. So now let's write the code for this. Let left pointer be 1 and right pointer be math.max of piles, and we will do the similar binary search what we do for other questions, and then let mid is equals to math.floor of we found the mid value now. And once we find the mid value, we have two conditions to check if it is possible with the k value. Mid is nothing but the k value, right? If it's possible to finish all the bananas in the piles within h hours. So to get that, we can have a total hours. So let me write get total hours. So I'll need piles and I'll also need k. In this case, what will happen is I will need total hours. For initially total hours will be 0 for let pile of piles. I will calculate the total hours using math.ceil of pile by k. This will be my total hours, and I'll return total hours. So what will I have to do? If get total hours of piles with the mid value is less than or equal to h, that means we found an answer. So we are going to update our answer with math.min of answer comma. Okay, we did not declare our answer variable. Answer will also be equal to the max value, which is nothing but r, answer comma mid, and then we are going to update our r to mid minus 1 because we already found a better answer. So we are not going to look for any values greater than the mid value. Otherwise, we are going to just update mid plus 1, and towards the end we are just going to return our answer. Now let's try to run this code. Okay, let me check. Okay, this should be an arrow function, just missed it. Okay, it runs, and let's submit it. Cool. So now let's also understand the time and space complexity, because I have already discussed it. I'm just noting it down now. Log of max of piles value into n, considering n is number of elements in the piles array, and the space complexity is basically nothing, it's big of constant time, so it's big of 1. I hope the solution is clear. Thank you.